Good evening, ladies and gents. We're going to go ahead and put together a video key for you, me and Mrs. Bax, to help you out studying for this quiz. This test we have coming up Wednesday, Thursday this week. Now, that's important because it's really going to control your grade, at least for a while. We know we don't have a ton of grades in here, so every grade is very, very important. This test is going to be all about solving. Now, the main feature of this test is going to be like setting up and solving a contextual problem, and then solving using the principles of Trig. But also in equal parts, like be able to explain like how this whole system actually works, like how it's built. Hint, hint, it has a lot to do with similarity of triangles. The other thing that we're going to kind of test you, or at least make sure that you're able to do, is to use this trig sheet. It's really the premier solving tool for this type of work. So make sure that you are indeed able to use it, and you'll see that pop in and out as we're going through some of the problems. I'll try to break them up logically, but it's probably going to be in multiple parts, like you've seen last semester. So let's go. Let's do it. So the first problem, just a little problem to start us out, is going to be this question about the ladder, or at least ladder leaning up against a building. So here's the best advice I can give you. Every time you draw something in your diagram, it has to make sense in the context of the problem. So you have to really guard against just like randomly drawing lines everywhere because you think, well, I got to make triangles. But instead think like this line represents something super important. And so if you're not drawing the line in a way that makes sense in the problem, you're probably doing it wrong. Anyway, let's get to it. Now the other thing I'm going to encourage you to do is try to make a very literal drawing. Meaning, like if it says, hey, a ladder is leaning up against a building, draw it in. Okay, so there is my building, super straight. And now we have this ladder that's leaning up against a building. And so I'm going to draw that. That's my ladder. It doesn't have to be beautiful, it just has to be representative of the problem. And again, it goes back to what I was saying. Everything I'm drawing makes sense in the problem itself. Now, here's the part that's going to be confusing. The angle of elevation is 72 degrees. Let's go over here just for a moment and talk angle of elevation. So an angle elevation is a angle that rises from the horizon. And so angle elevation, or later angle depression when we talk about it, always has to start in a horizontal fashion. And then what ends up happening is, in this case, since it's elevation, we're going to move up. And so angle elevation literally refers to this guy right here, the angle at which you started the horizon and move up. Now, you'll see this in lots of different contexts. Like it could be the concept where you're like looking out, and then you look up. That's an angle elevation. But it can also be the case where you're on the ground. And so like an equally common situation is that you are laying on the ground in some way, and then something is shooting up from the ground, in this case the ladder. This is a mistake most people make. Angle elevation refers to ground and then up, okay? So when it says the angle elevation is 72 degrees, we have to kind of connect that to what we already know, which means, boom, that's going to be 72 degrees. Now we can also surmise that's going to be a 90 degree because we don't make buildings intentionally crooked, although mine is kind of drawn that way. And so we're really setting ourselves up with a nice right triangle. Now this puts us in the lead for right triangle trig, because now we can compare it to a similar right triangle and maybe set a ratio. So the question itself is, how far is the base of the ladder from the building? Let's stop right there and let's mark that in our diagram. So how far is the ladder from the base of the building? We are talking about this distance. I'm going to call it the x, just because we got to choose a variable. And then we're also asked a secondary question, how far up the building is the ladder? And so we're asked for this distance here. I'm going to call it y. So I expect to see at least one trig problem here, maybe Pythagorean theorem or another trig setup. But let's get to it. Let's go ahead and solve for the x first. So I'm going to set myself up for success. I'm going to go ahead and write in this, like the reference triangle is equal to the actual triangle. Now these of course mean the ratios themselves, like not the triangles, but rather the ratio of the side lengths. And so now we have to do some examination of the object. I need to pick a reference angle, I need to pick a ratio. So the ratio in this case, I'm forgetting one piece of information, let me go back. We're also told it's a 16-foot ladder, which means that's 16. The reason why I had to put that in now is because it actually is really important now. Because if I'm solving for x, I need to pick another side length to write in a ratio with x. And I'm not going to pick y. Like y doesn't make any sense here because I don't know what it is. I'm going to pick instead 16. If I'm picking the reference angle of 72, which I will for this problem because it was given, it looks like I'm going to be dealing with the adjacent side, which is the x, and the hypotenuse, which is 16. And so I'm going to go ahead and write in that literal equation, adjacent over hypotenuse for a 72-degree angle should be the same as an adjacent over hypotenuse for a 72-degree angle. Okay, so here's where I'm going to push again the fact that you need to be writing these first two steps. I know some of you guys are like, well, I don't want to write those first two steps. Either that's just being lazy or being confident. Either way, I'll tell you this: the success level goes way up if you write in these first two steps first. If you're not doing it, you're allowing yourself to really start to make some mistakes. Whereas now, I've stepped away from the problem for a minute. I had a little conversation with you guys. I can come in and actually start writing in the ratios right away because I've done all these preliminary steps. So here we have 72 degrees adjacent. That gives us the x. Hypotenuse is 16. Now I do need to go to my trig sheet to pull the other values. I need adjacent over hypotenuse for a 72-degree angle. 72 means I'm going to read from the bottom up. Adjacent over hypotenuse is going to be the first column now instead. So we go all the way up here for 72. 72. Looks like it's 0.3090. Now from here I have some options which I can actually take to solve. Your choices from here are purely yours. I'm going to go ahead and throw it over 1 and do some cross multiplication. And so I have x is equal to, let me get a calculator. And so the cross multiplication the other way. Oh, you can't see that. My apologies. So I put it over 1 here and did some cross multiplication. So x times 1 is x. And now I need to take 0.3090 times 16. Okay, so we have 4.944. Now that should make sense in the context of the problem. Like 4 feet doesn't seem an unreasonable distance to be away from the wall. But we'll do some checking on the back end here in a moment. I'm going to go ahead and keep in trig to solve for the y value. It seems to make the most sense here. So I'm going to set myself up for success again. So reference triangle is equal to the actual triangle. Now I have to pick a ratio again and a reference angle. I'm going to pick 72 again since it worked the first time. Looks like this time I'll be checking the opposites, and I'm going to use hypotenuse again. Hypotenuse. So opposite over hypotenuse of 72 is equal to opposite over hypotenuse of 72. So the actual triangle stuff I'm dealing with will be y over 16. And now I need the opposite over hypotenuse for 72, so let's go back to my trig table. Again, bigger than 45 reading from the right, opposite over hypotenuse is going to be the second column. And so 72, second column, double check quick, 0.9511. Okay. So it's 0.9511. Now again, I'm going to go ahead and put this over 1 and do some cross multiplying. And so I have y is equal to 0.95. See, 0.9511 times 16. And so it looks like I'm getting a y value of 15.2176. Now before we move on, and before this first video ends, it's important to note that we should check our work and check especially the reasonableness of our work. So if we look at 15.2176, that's not actually a bad value here for a couple different reasons. Number one, it's going to be the biggest length. This across on the biggest angle. And also it's going to be less than hypotenuse, so that seems to fit. If that angle is 72, that means the angle at the top here has to be, 18? And so again, 0.4944 makes sense in this context because it's going to be the smaller side length. It's across from that 18. And so there's lots of ways you can kind of check yourself to make sure that you're on the right track. Even if you didn't have a key, you can use that good information about the hinge theorem, where you have the biggest angle across from the biggest side, and the smallest side across from the smallest angle. And so our values at least make sense in that context, all right? So I'm gonna stop the first video here because it's kind of running long anyway. I'll see you guys in the next part.